Let's start coding for k-means first. So we will be creating k-means clusters. Before that, we will be loading two packages using pacman package. There are load multiple packages at once. So I'm loading dplyr and ggplot2 package so that I can use their functions in my session. Then the dataset I am using for clustering here is empty cars dataset. So this is the first 6 rows of empty car. I will be subsetting my data and will take MPG, weight, horsepower, and AM, that is transmission from this dataset. Let's subset this data using square bracket command. Let's check this data. So you can see the data that we will be dealing with is the MPG, weight, horsepower, and transmission. Now let's start building model for k-means. In order to create a model, we need center points, as we discussed in the slides also, that there should be a specified number of clusters that we want. It can be imaginary, or we can get an optimal number of clusters using elbow method. So first we are taking imaginary clusters here. So I am taking 3 randomly, that I want 3 centers, that is 3 clusters in the dataset DF. And the formula to create k-means is k-means. I am saving it in variable km1. Let's execute this command. You see there is many of the data available to us. If you check the data, so k-means clustering with 3 clusters size 5, 10, and 17. So it tells you that 3 clusters have been created with size 5, 10, and 17. So in empty car dataset, if you remember, there are 32 observations. So those 32 observations has been divided into 3 clusters. Now what we have is these were the R variables, and we have means of each of the cluster. So in MPG, there were 3 clusters. So these are the mean of MPG of 3 clusters, weight mean, similarly horsepower, and transmission mean. Next, it is a clustering vector. What does it mean? In which vector, in which cluster, which car belong to? We will be combining this data so that we can understand it better. Then there is the components available to us. So we have clusters here, then there are centers, then there is total of SS. So these are the different features that are available with k-means here. The main elements that we want here is k-means, the cluster means, and the cluster vector here, and the size of each of the vector. So for that, first what we are doing is, let's see bind. So we are combining our data set DF and the cluster number. This is our data set, and this is the cluster number along with our data set. So Mazda RX-4, it has been allotted in 3rd cluster. Similarly, this car has been allotted in 2nd cluster. This has been allotted in first cluster. So this is how different clusters are being created. If you want how many observations are there in each cluster, so for that, the command is table km1, that is the name of the variable in which we are saving our model $cluster. So you can see in first cluster there are 5 cars, in second cluster there are 10 cars, and in third cluster there are 17 cars. Next, what we are doing is we are subsetting our data, all those rows wherein the cluster, all those cars that are allotted in cluster 1. So these are the 5 cars that are allotted in first cluster. So this is how you can subset your data easily. You can filter your data, you can arrange your data with the help of clusters. Like in this you can see I'm using dplyr package here. So in the data set DF, I want to filter all the rows, like all the cars those are in cluster 2. So you can see all these cars are in cluster 2. There are 10 cars that are in cluster 2. If you want to arrange your data, what you can do is df dollar. So I'm putting piping symbol here. Then I say arrange k arrange km1 dollar. So you can see our data frame has been arranged as per cluster. So these are the first rows that were including the first cluster, then the second cluster and the third cluster. Now we will be calculating the means of all the variables using clusters. For that, what we are doing is we are taking the data frame and saying group it by the number of clusters created from k-means and summarize all. Summarize all means it will be taken for all the variables available for us in the data set. Then I'm putting the name of the function within the bracket. So I'm saying mean and any removal should be true. So if there is any a value that is missing, so it will be removed. Let's execute this command. So you can see there are 3 clusters, 1, 2, 3, and for each of the variable, their mean value has been displayed. Now what we will be doing is we will be creating plot for this k-means that have been created, and that is these 3 clusters. We will be plotting them. For that, the library that I am using here is Facto Extra. So you can download it from packages or give the command install.packages within the bracket Facto Extra. Then you have to load it in order to run the functions of the package. Within this package, the function that I'm using is pvis underscore cluster, giving the name of the model variable and the data for which I am creating the model, that is the df data set. Now let's execute it. So there is some error here, error in grid call graphics, cannot pop up top level view. Okay, so I just ran the some of the commands, initial commands again in order to remove the error, and you can see the plot here. So let's zoom it and understand this graph. So whenever you are plotting a graph using Facto Extra, you can only plot 2 dimensions. So this is the first dimension and the second dimension. And you can see there are 3 clusters, cluster 1, cluster 2 and cluster 3. So the red one is the first cluster that was created for 5 cars. Then blue one is the car, the 10 cars that are in, sorry, it is the third cluster that has been created, wherein the number of cars are 17, and these are the 10 cars. So these are similar within, and you can see they are different from each other in different clusters. So this is the feature of clustering, wherein the similar cars with similar features, they are grouped together, and they should be different from each other cluster. Each cluster should be different from each other and should be homogeneous within. Let's go ahead. Now what we will be doing is we will be choosing best number of clusters, or we can say the optimal number of clusters using elbow method. So in elbow method, there are 2 types of method you can follow. That is either Facto Extra package, or you can use NBClust method. First, I am using Facto Extra method. I am setting seed here in because most of the time when you are running your codes, your output is different every time you run that code. Once you set that code, the seed it will give you the same output for this session that you are using. So for that, I'm saying set.seed. You can fill any number here. I just filled 1, 2, 3. Then the function that I'm using here is fviz underscore NBClust. Within the bracket, the name of the data frame. Then the method you are using here is k-means, and method for the method in order to get the number of cluster here is WSS, which means within sum of squares. So it will be your clusters will be based upon within sum of squares, and let's execute it. So you can see a graph has been created for the optimal number of clusters, showing a elbow kind of a graph wherein there is. So what does it show is these are the number of clusters here on the x-axis, and this is the sum of squares. So your numbers should be optimal in order to get a optimal sum of squares here. So for that, you can see there is 2, 3 and 4, which is a right number for our clusters. From these three, we will be choosing one of them. Now what we will be doing is, we will be doing taking our next method also and verifying which one of them is more suitable for our number of clusters.